All right, week 12. We only have a couple of weeks left. Everybody can clap for that. Yay, it's good. So we have some things we want to kind of clean up. So at this chapter, we're kind of doing a cleanup, and we're talking about security, but by design, and some of the things we might put in place. How do we structure some of our networks? So we're going to talk about some of the functions, some of the devices that are out there. We're going to talk really quickly again about wireless networks and some of the security pieces that we want to put in there. So there are a couple of lab simulations that are in there, and these will probably take a little longer than some of the other weeks. So when you're having to type in commands, so you're doing one in Ubuntu and doing it at the command line, so that one's probably going to take you a little longer than some of the ones at the beginning of the semester. So what we're really doing is looking at all these devices. So now we're looking at our network, not just we have a router, we know that we've got equipment on it, we've got devices, we have IoT devices, all these different pieces on there. And so now we're going to kind of look at from that security standpoint of what might be involved in some of these. So we have a term that's called layered security. And so it's like an onion, to quote that Shrek line about you have to keep digging down through the layers. And what we're really doing is trying to present that in terms of layers. Well, think about a prison. A prison has multiple layers of outside physical security. You have an outside gate, you have an inside gate, and so they have different layers. And we're going to design a network that has that same kind of structure. So in other words, there's not just one obstacle, there's multiple obstacles to get in. So one of the things that we see a lot is a proxy server. And a proxy server by itself doesn't necessarily make a security device, but it can be used in a security sense. So a proxy server takes all your outbound and inbound traffic and processes it so that it looks like it's coming from one local machine. That's really its first line of function. As a security tool, it hides the addresses and the inside information from the outside world. As a performance tool, what it allows you to do is minimize web hits. So if we have a very large campus, more than one person is going to go to Huskers.com at any given time if we're here in Nebraska. What that allows us to do is it grabs that page in a lot of cases, and if it hasn't been updated since the last time somebody used it, it's stored locally, so we don't have to go outside of our network to get some of this information repeatedly. So the idea of a reverse proxy, so it provides services, so our internet clients, so it sends them internally. So updates for things are done internally versus outside. So if I have multiple web servers, for example, and I only have one outside IP address, it's a way that we can direct them to the correct client if I need to do that. So sometimes it makes more sense to see it kind of in that graphical model of where something like this proxy server sets in. So that proxy server, our traffic to all of our workstations goes through that proxy server, or can go through that proxy server, connecting us to that internet. So it almost makes more sense to think of it in line with, so the internet goes through that, and it allows us to create rule sets, allows us to minimize traffic so we can conserve our internet resources. So it gives us kind of a unique place that we can store data. One of the things that we can use is something called an access control list. So access control lists we can put in typically in the router, but we're starting to get more power at other devices, so sometimes we move these to other devices. In fact, in some cases, we move access control lists all the way up to a software application on a personal computer or on an individual device. So it's a it's essentially a filter. So we say these are the packets that are going to get in. So this traffic that follows these rules are going to get in. So we can block it by IP address internally or externally. So we could block things from going from a specific computer on our network. We can block them coming from a specific location, on a specific port, types of protocols, types of applications. So it really is nothing more than a rule set that we build. So it gets this packet. It says, here's my rule set. If it doesn't meet those criteria, if I have an implicit deny, in other words, I deny everything unless it hits my specific rule sets, then I deny it. Otherwise, if it matches some characteristic that we said was okay, then it goes and gets sent on to its target. Well, our routers can be very complicated in that sense. Oftentimes we break our network into separate segments, and so our routers may have multiple outputs. And so, for example, the router we have in the back actually has 8 different assignable LANs we could create. So we could put in different rule sets for different networks internally. And we can also set up routes and lists for incoming and outgoing traffic. So we could deny traffic going out if we needed to. Most firewalls we typically think of as being inbound only, but we can actually deny traffic going out also. So here's our outside of our network, wherever this firewall is at. If it passes the first test, then we can permit it. If it passes the second test, but at any point it's got to pass whatever rule sets we have in there. Otherwise, we dump it off. We just drop those packets. We drop them. So there's a problem with this, is we have to configure these rule sets. The second problem is the more of these rule sets we have, the more processing power it's going to take to do that. So here's some examples if we're inside of a Cisco switch. So I will say that this chapter, when you're reading it, reveals a little bit of some Cisco bias, but we'll let it slide for now. So we're creating this list. So here, the second example, because I can point to it a little easier because I'm short. So permit traffic from 2.2.2.2 to 5.5.5.5. So this is my computer name. This is the location coming in. So I'm allowing a traffic to come in from 2.2.2.2, just a number we picked, versus, and we can allow it to go to 5.5.5.5. So if that rule, if we get a packet that comes in and it says, I'm from this address, I'm going to 5555, yep, that packet can go through. So we can create hundreds, if not thousands, of access control list items, but the more of those we have, the slower this process becomes, because it's got to go through all of those particular items. And remember, in a larger network, we're transmitting millions of packets, so we have to examine every one of them. So we sometimes use this. This is not all we do, but it has a specific purpose. And so we have to be careful of making sure that we're not using it for every specific application. So a firewall, we hear that term. If you watch any of the CBS shows, if you watch NCIS or any of the TV or movies, you always hear this term firewall being thrown out. And a firewall is really nothing more than a device that's got a rule that blocks traffic. All right, well, we can filter it, we can block it. So where do we put firewalls? And what do we need with them? So typically Typically, this is what the scenario that you would imagine. So here comes the internet, it hits the firewall, and then we hit our router. Well, if you're buying a device for your house, you can buy that little all-in-one device, and it'll say, hey, I've got a router, I've got a firewall, I've got everything all in one. And sometimes they do, but probably not at the price point Best Buy is selling it to you. So this is typically how we're going to configure a network. So if we have this model in mind, internet, firewall, router. So we're blocking that traffic a little bit. Doesn't have to be the only place we put it, and sometimes we put some in some other locations. But we're now seeing as devices get smarter and smarter and smarter, processing power is cheaper, RAM is cheaper, memory's cheaper. And so now we're actually seeing some of these firewall features ending up on switches. We're seeing them certainly integrated into routers. Even some of the home level stuff has some basic firewall features. So other network devices, we can see a firewall on all kinds of things. And the weird one we see a lot now is on your computer. And in fact, Windows has a host-based or computer-based firewall that has this set of rules and says, hey, we've seen this traffic. These are things we don't want to deploy. So if you see a commercial firewall, you might see something like this. These are for small businesses applications. These are certainly not high-end firewalls. But a device like this Zyxel, because I've actually used models very similar to that, you're talking about $400 to $500 for the device. It'd be fine for a small business of 20 people, 40 people maybe. What's important with those is I'm buying the license. And that license means with any of these guys, FortiGate, Barracuda, any of these companies, that license means that I am getting regular updates, and depending on the service, it may be hourly in some cases, for those rules, those firewall rules. So they have a network operations center. They're watching what's happening in the world, and they're seeing that we have traffic from Croatia, from this IP address that's bad. It'll push out to that firewall a new rule that says, hey, this traffic should be blocked from this particular avenue. So these are the next step up from those all-in-one devices we see at our house. They're not horribly expensive for a small company. They're certainly not cheap either. And so that license is nearly the cost of the hardware. So I think on the Zyxel for a model like that, if I remember correctly, and I could be wrong, I think the software was about $300 a year to add to it. But that's what you're really paying for, is that feature of I'm getting these updates, I'm getting security pieces, I'm learning from that. So those firewalls, starting from kind of the simplest firewall, so the simplest one says, I see the traffic coming in, and I look at that header, and I see, hey, where it's going to go, where it's coming from, and I can have rules set up so to block that. So it's really a form of that access control list. I can typically manipulate those rules a little bit. But this is kind of the packet-based idea is kind of the first line of defense. It's kind of that simple one. And so if you get a cheap router and it says I've got a firewall, that's what it's doing. So here we have traffic coming in. It's hitting this firewall, and it says, oh, nope, that's not an address that I'm allowed to send in, and it rejects it and sends it back, or just drops that packet. Well, we can do it on the inside too. So we have traffic that's going out, and so we can block traffic to specific sites. So one of the things we do, we know that a lot of the ransomware, a lot of the command and control for zombie networks, we know that it goes out on the Merck network or the IRC network. And so we can block certain ports. We do that, and we only allow certain items out. Our network's a little more secure. So some of the things we can do, we can look at source and destination, the ports it's going, if there's any flags set, what type, whether it's using UDP or ICMP, we can block those. So we can block initial packets if we needed to. So we can block with a lot of different criteria, and every day we come up with new models and new things that we can do. So we can completely block a port if we know that there's an issue. We can magically turn on a switch, or the rules will say, hey, we're going to block a port completely. Well, as these devices get more sophisticated and as our needs grow, we start to add a lot of other things that we can do. So encryption, in other words, we're scrambling that data. So a lot of our larger networks now, the entire network is scrambled. So maybe you have some kind of centralized management, or the term you see a lot of times is this cloud-based management, or a single pane of glass. In other words, I can log into like a Cisco Meraki system, and I can see everything all from one sheet, whether if they have switches, a router, and all those different kinds of things. We might actually be able to add the idea of content filtering. So not just where this packet's going, but we can actually get to the idea that we can log in and see that packet, what's inside of it. So it takes a lot more computing power to do that, but we can actually open those packets up and we can see what that data is. And we can set rule sets up based on that. We have a lot of monitoring and tools so we can see what's going on in traffic. So we can monitor, maintain, see what's going on. I would say the encryption piece is probably one of those that's starting this idea. And once we start that encryption path, then we're a little committed to it. But we've started to see that those traffic on our network, internal and external, needs to be protected. And it's a model we're starting to move to, is that idea of scrambling that entire network. The other one that's been really interesting coming out, and tends to land to start with on the firewall side, is that of VPN, virtual private networks. So now that we've had our COVID-19 and we've started to move more and more employees to their houses, now we're using that VPN feature to allow us to come in seamlessly and encrypted and protected onto this network. Well, if we don't want to call it a firewall, because typically a firewall says, hey, this is my role, I'm going to do X, Y, and Z, and we want to expand that a little bit, the next term we have, and some of this is some marketing jargon, is the idea of something called a UTM, or Unified Threat Management. Sounds like something you probably need to go to the doctor for, but it's really, what we're talking about is we combine all these different layers. So we combine a firewall. So we combine content analysis. We combine a VPN. And we put it all into one device. And so what we run into, it takes a lot of processing power to run all those functions. What I have seen in the lower end devices that say they're a UTM, if I implement all those devices, I slow my throughput down tremendously. So that's one of the issues you see with them. So like that little, from a couple slides ago, the little Zyxel. It's a decent little firewall, and I've deployed several of them. But if I turn on every feature, and I buy the UTM license, so it's got all the features known to man, I try to run a lot of them, my throughput drops dramatically. And so, in at least one location, I have a 100 meg or greater fiber, and it really draws it down to 10 or 12 megs per second. So they don't have a ton of processing power, and they need it, so you tend to have to step up a little bit. So make sure you're aware of where those are at. So the next level then, and again, this is some marketing, is that idea of the next generation firewalls. And so these are application aware. So not only is it just traffic, but they actually know that you're working with a Microsoft Word file, and it's going to Microsoft's cloud in the sky. and they know that you're working on a website. So they're application aware. And again, it's even more horsepower to run something like this. They can adapt to, or we can force them adapt to different applications, users, devices. This is kind of that next level we're going to, where they're starting to see exactly what we're doing, but we have to have that person in there being able to configure them. And that's where we run into the biggest issue. It's misconfigured. And by misconfigured, it's not really what you think. Misconfigured means it's too strict. So we always are in this balance of, do we deny everything and just make the workforce a very horrible place to work, or do we allow everything and make life convenient? So we're balancing security versus convenience. So that's a really difficult task. And now that we've got, for example, right now, hospitals are being targeted. If I'm in a hospital, I've probably ratcheted my security up, and I've made life very inconvenient for my staff. There's not really any perfect answer. It's a balance. So I can either irritate every user so users can't send and receive data, and that makes my network really secure, or I open up holes. And so the book calls punching a hole in the firewall. You've probably seen that term on every movie known to son. Hey, we're going to punch a hole in the firewall. And what we're really doing is making some kind of a rule exception. That's really all it means. It doesn't mean we're literally creating some kind of a hole, but what happens over time, we've made all these exceptions, we've made all these rules, and that firewall gets kind of leaky after a while. So we need something else. So there's some other tools that we can use, and usually we use these in conjunction. So we already got our firewalls up, or our UTM. And now we need something to see what happens if we have an intrusion. So IDS, Intrusion Detection System. There are UTMs that include this. Great. Or the next generation firewalls, or whatever our next marketing wank is going to be. So this is taking our traffic, and it says, I'm kind of keeping a log of what's going in and out of our network, and I'm looking at it to see if it meets my norms. So the first one we do is based on statistics. So in other words, if my network is normally not a lot of data being transmitted at 5:30 p.m., and all of a sudden at 5:30 p.m. I start seeing a bunch of data, that will probably generate an alarm. Like, oh, wait, why am I sending all this data when I think the company's at rest? Now, it may be legitimate. Maybe we started a new backup service, and that backup service chose 5:30, or we chose 5:30 for it to send all its data out to the Apple Cloud or whatever cloud platform we're using. So it may be fine. But statistically, it's different than what has been done previously. So we look at those things, weird IP addresses, anything that's outside of the norm. To do that, we also have to determine that baseline. So the minute I turn this on, it doesn't know anything yet. We've got to generate a baseline. The other one is more of a heuristic or rules-based. So we know that there's patterns. So we know patterns of attacks or signatures of code. So we can actually run that and monitor and see what's going on. So if all of a sudden I see patterns of data that look like there's a rootkit or a zombie or who knows what on our network, then it should alarm me and say, hey, there's something weird here you might want to check out. So to deploy this, we have a lot of different ways we can do that. So we can put it on a single computer, so it monitors only a single host. Well, that doesn't seem to really do a lot. So I may do that if I'm monitoring a specific entity or a person in my network. Most of the time we make it a network-based. So it sits at the edge. we also can do something where we mirror all of our traffic. And so I've used the term port mirror before. And so our core switch, we take one of the ports and we mirror that traffic. So that switch sends all of that data out to port 44 or whatever it is we use. Now I can take that data and put it into my intrusion detection system because I've got the entire network. Everything on my entire network goes into that intrusion detection system. Okay, that's good. Now I have to find personnel to get those records and try to interpret them. Even if I set up rules to alert me, I typically get a lot of false positives. What does that mean then? When I see all these false positives, I'm probably not as alarmed. I see a result and I go, well, I can get to it after lunch. Meanwhile, my corporate data gets slurped off the network. So it's a start. Again, you have to have the personnel to run something like this. And it can only detect it. And I've seen some commercials that have been interesting. And so the one that I remember is the one that it's a cavity detector. And the guy goes in to get his teeth looked at, and the guy goes, well, I can't fix that. I'm just a cavity detector. And that's all IPS does, is it detects something. It doesn't actively change anything unless you do something or your network administrator. So, host-based versus network-based, how do we set those up? So, this might make more sense to see this then. So, in this case, our network system is sitting on the very top line. We've placed it where it's literally in line with all of the traffic going in and out of our network. So everything that leaves our company goes through that. Everything that comes into our company goes through that. That's one model. The other model here is putting it off of a switch that gets a core chunk of this traffic. And so we've port mirrored to it, or we mirror off. Even some of the routers will allow us to port mirror off. And so we could set it up that way. We could set up intrusion protection clients or devices anywhere we want to break up a segment. And we could also put it on a single machine if we need to. So we have a lot of choices, and it depends on which brand, which software, what hardware, whatever system we're looking at. You can even do it for free. So probably one of the most sophisticated ones is out there, open source, called Snort. You can deploy it, but again, you have to have those people and those resources to read and interpret that data that's coming in. It doesn't help you if it's flagging things continually, but you're not making any changes or not doing anything to your network. So we've got another marketing term. So a security information and event management. So it's really intrusion protection, but gone up just a little another notch and with a term that we can market. So this rule sets, maybe they sound it out a little better. You have a dashboard you log into every day. It's a little higher cost. It's a commercial product. We have to configure the rules that are going to trigger responses. So maybe it's less false positives because we've hand-tailored those rules. But we still have to have those network technicians. And that's one of the things we lack in a lot of cases is enough people to get these done. And that's kind of a common theme is we don't have enough people hours and people time to deal with all this data. We've got gigabits and terabytes and zettabytes and petabytes of data. How do I deal with it? And so your one IT guy that's also trying to set up all the computers and train the users and do everything else isn't also able to run that intrusion protection system. So smaller companies don't tend to even do this at all because they don't have the ability. They may subscribe to a service through a company like Watchdog or somebody else who will look at that data. but I think we miss out on a lot. So smaller companies, again, they're not as big a target in some cases, but they're missing out on some of those also. So switches are kind of the backbone, pardon the pun, of our network. And one of the things we want to do is we want to set up our network so that it's protected not just from malfeasance, but also from things breaking. And that happens more often than you would like to think. So a fan on a switch fails, the switch fails. How do I avoid taking down an entire network? So the term we use a lot is something called fault tolerant. In other words, we like redundant components. Something that if the switch dies, or a switch dies, in some cases we can switch over immediately to something else. So core switches typically are where we're talking about. We typically don't multi-home PCs. In other words, they only have one connection to a switch. But our core switches, we typically have redundant paths. So if each one of those switches is at a different building, so switch B and D might be in the same building, and A and C are in a building. So we have these multiple pathways. So we can have a pathway here, we can have a pathway here, and we try to create some redundancy. So if something breaks, we can transfer that traffic to the other path pretty quickly. Now, even the switches to all the individual computers, we can't typically have redundant ones of those online. However, if we have that switch configuration, so switch F over here, and we have its switch configuration saved and we're using some tools to be able to redeploy one, we could switch out a physical switch there pretty quickly, and you're going to inconvenience probably at most 48 people or so, because that's a typical data switch is 48 units on each one. Redundancy is good. We want multiple pathways, except we also don't. So multiple pathways create loops. Loops are good, except we don't want our traffic to circle in that loop forever. And so we have to deploy something to break these loops. So what we deploy is something called spanning tree protocol. And so spanning tree says, I see the loop, I'm going to calculate it, and I can either manually or I can, via software, block one of those loops. So in the case of the network we configured just recently here, spanning tree software would block all these redundant links. Now, once that other link, if it dies, or a switch dies, or something else goes wrong in our network, it recalculates those pretty rapidly and would then go, oh yeah, now I need to change my pathway. And it allows you to do that pretty quickly. So spanning tree protocol allows us to make these decisions about how we're going to create these loops. Or how do we manage the loops? We want the redundancy of a loop. We need to be able to disable it. So spanning tree has its own protocol or own little language. Great. So here's where I have ran into that problem of multiple brands not playing nice to each other. Specifically, some of the Cisco stuff doesn't like to play nice with others in terms of spanning tree. In theory, there is a protocol and a language between all of the switches that would communicate and say, hey, we need to block this path, and this path. Sometimes we have to manually set that up. And then we have Cisco and some of the other brands that don't necessarily play well. So it's one of the areas I will say, you know what? I know it's a pain in the butt, but it's probably an area where you want to be homogeneous or the same on all your switch brands so that those kinds of issues don't happen or less likely to happen. Because the other problem in terms of problem solving then is you get brand A blaming brand B and brand B blaming brand A. So it becomes a problem-solving nightmare when you have multiple vendors in there. So to make life even better, is some companies have even made their own proprietary versions. Oh, again, Cisco. So other ones have decided to follow the standards. So if you're using all Brocade or some of these other switches, you're okay to intermix, but it's really one you need to plan out. And when we're talking about these switches at the core, we're not talking about the $150 switch you buy at Walmart or somewhere. These are typically, $4,000 to $10,000 switches at the core or more. And so you're not going to go off and just start cost saving them by buying one. So, and they actually show you here the other thing we can do that's pretty important, and almost every switch will do it. How it does it depends, is we can turn off ports. Well, if a port doesn't have anything connected to it, that's just common sense security to say, hey, let's not connect it. So we can do it manually. We can have it disconnected at that patch panel level, or we can actually disable that port also. And so in almost every switch, we can go into and turn on or off ports. Now, it's another step. So again, you're balancing security versus convenience. So now you have some new equipment you need to plug in. You've got to go into the switch configuration and turn on that port. So documentation about what network jack leads to what port is pretty important. Otherwise, it gets kind of ugly. You're trying to, I'm going to try to trace this out and figure it out. But it's a great security thing, and here's the problem. Very few people do this. Very few people do that. Really hyper-vigilant companies, not only do they disable it in the switch, they disable the jumper, and just out of sheer paranoia, in a lot of cases, they install locking devices on the RJ45 jacks in the wall so that you have to have a special key. Now, any one of those by itself we could get around, but when you have that layered idea, that makes life better. So in case somebody accidentally put a network cable in to that, you wouldn't be able to get through. So in here, for example, none of these are actually connected at this point because we've done some network changes. I know that, but if I were coming in on a reconnaissance mission, I wouldn't realize that until I started plugging in and seeing that those ports aren't connected. So this is a really a critical piece, I think, of security, is maintaining that physical security posture. Because we put data jacks everywhere for convenience, because it's cheaper when we build a building or we're redoing a building to put them in everywhere. That doesn't mean we have to have them connected and live. And if I'm local into a network and I can plug something in, I can usually do some kind of damage. We also need to deal with our users. Our users, we need to figure out who's on our network, how long they've been on our network, what they're doing, are they authorized to be there? So we have this AAA model. So authentication. So we have to verify their credentials so that they can gain access to some kind of a secured resource. Authorization, in other words, what we can and cannot do, and then some kind of an accounting. So where did they go? Why did they go there? What reason were they there? So, a couple of different ways we can do this. So there's the idea of a local model. So they're authenticated at the computer. There's also the network model where they're authenticated on the network at some point. So if I'm storing them just on the computer or local, that means every computer has to secure its own resources. So monitoring and managing that gets pretty ugly. And we can actually switch a computer. So one way we get around security sometimes is we can switch a computer off admin on network to local, and if they don't secure those local passwords, we can install software Then they jump back on the network, get authenticated, and hey, we installed a keylogger or something else on there. So local means you have to authorize your own items. This is showing going on this computer from local, so they're in a work group essentially, to the Active Directory. And so we typically use Active Directory or something similar because that authenticates them not at the local PC network, but it authenticates them at the server. So that gives me a couple of things. It gives me a lot more power. I can control resources centrally, which is nice. I can see, and I can even set up people to have resources by time, how much time they've been logged in. I can only let people have access, for example, 8 to 5 if you wanted to. I can log in that they can only log in on certain computers. I can do what's called geofencing. So if we're on a laptop, if you're not in the building or you're not in one of our facilities, you can't log in. So there's a lot of things that we can do to restrict you based on that network login. So we have a couple of models in there then. We have this idea of role-based. So we create groups, and that group has a set of privileges. So maybe I set up a group called Manager, and we know they all get access to all of the printers, and they get access to a folder that we share out for them called Manager. Maybe they can install some software. All of those are inherited off of that role, and so we assign them a role-based network. So that looks like this, where we're assigning authorization based on that group. And so there's some built-in, so if you're using Active Directory, there's a bunch of built-in groups. You can create your own. And certainly we encourage you to do that because that makes it a little more secure. It's not a known group that you're already authorizing to. The other good thing about going on a server style of authorization is you have these event viewers. And so everything that's logged into that server, we can actually view. So I can see when you logged in. Oh, you took 3 times to try to get your password in. And so I can start creating rules and look at other things. So maybe what I figured out is you've tried to log in every 3 minutes. And you would try 3 passwords and then quit. And that might tell me, I think they're trying to use some kind of a cracker tool. And that's the rules they've set up on it to try to not make me suspicious. So it's always kind of a cat and mouse game of this network access control. Is how do I get people to be productive and also be safe? So sometimes we also perform this idea of we monitor the system and we look at it to make sure that it's got the latest Windows updates, for example. So a network access control, we can put in security pieces in there. So, you can't access our network until you've updated to this. Or you can't access this until you have our version of FortiGate client for a virtual device in there. We do that by putting in either a persistent or non-persistent agent. So if it's a device that I control as a network administrator, it's a persistent agent. So in other words, it's permanently installed. So that computer will allow me to communicate with my network via that client, and then I can make rules based on things. Because I don't want a computer to join my network if it's infected with malware. So I need to look and make sure that your antivirus is on there and it's ran. So there's also ones that the book uses the term dissolvable agent, so it installs just long enough to verify and then disappears. So if I'm on a guest network, sometimes we use those. Or if I'm on a BYOD device network, we'll use a dissolvable. In other words, it installs temporarily once, and then the next time you log in, it's got to do the same thing. If you don't meet all the requirements, perhaps I throw you off on a guest network. So you can't get all the resources, you can't get the printer, but maybe you can get internet access. Or you can't get shared folders, but you can get those. Well, to do that, we of course came up with all kinds of languages and protocols because we needed some more acronyms in here for you. So the most common Active Directory or service or directories type of service is actually called Active Directory from Microsoft. It's kind of weird that the corporation networks are based on Active Directory and Microsoft Windows Server. All the internet service information pieces are really based on Linux, and so we make them coexist. There's some others. There's OpenLDAP. OpenLDAP can do pieces, but Active Directory, really Microsoft has done, and I hate to give Microsoft praise for a lot of stuff, but Active Directory, they've done actually a really nice job. And so most of your Linux clients and everything now are Active Directory aware. We can actually join them into our network in some fashion or another. Active Directory uses something called Kerberos. And Kerberos gives us a ticket. So it's another way that we can authorize who's on our network and what their abilities and roles are. So Kerberos doesn't care what platform it's on, so that's one of the good things about it. It uses an encryption service. So all of our data is scrambled. So you'll see a couple terms. There's a key distribution center. They use a ticket. They even come up with these really cool terms like supplicant. And a supplicant means just somebody applying for. Why we had to use that instead of just saying something that's applying. But it works something like this. And this makes maybe a little more sense. So your computer says, I need a ticket, please. And so it will send me your ticket. And it'll do that. It can even do that based on services. So ticket for internet may be one, ticket for file distribution services could be another, ticket for the printers. So those tickets can actually be time limited, usage limited, so they can have a lot of information based on what we want to send. So they certainly have timestamps. One of the big issues, and we'll probably see it here, is they're super sensitive to time issues. So if you have an old computer you haven't turned on for a while, you turn it on, and it doesn't update the time correctly, you're probably not going to get logged in through Active Directory until you update that clock and make sure those time, because it uses that time series to make sure that you are accurately in the right area. So tickets can have a lot of information. Well, there's a problem with all of these so far. They use my buddy that I hate called passwords. And so everything really has been based on passwords. So our login to our network's based on passwords. Our login to almost our Wi-Fi network based on a password. Well, in a lot of cases, what we are moving to, and we're trying to do some of that here in our college, is the idea of something called an SSO, or single sign-on. So single sign-on means I only need to have one password to get into all of my applications, all of my software, everything I need to do my job. When I did some studies, and I was researching for an argument at a hospital system to help out the IT administrator, what we found out was that the typical practicing physician or mid-level, like a nurse practitioner, physician's assistant, has 192 passwords to memorize and try to keep track of. And then we're telling them every 60, 90 days, whatever it is we've set up, we're going to change those. And they've got outside entities, so they log on to see like radiology images, it's another password. And it's really untenable. We can't do it. So single sign-on is a model to deal with that. So in a lot of cases, it's actually an appliance. We can do it on our own, and we've talked about something like LastPass. LastPass has commercial versions of that. There's a lot of other ones out there, Impravera, so there's tons of them out there. So there's advantages. It gives you that convenience. So maybe I only need to authenticate a biometric device and a password or something, and then I'm into every system. So the disadvantage is, guess what? Well, now I'm into every system. What happens if this breaks? So we have to be very confident about our password. So that master password that you're going to use has to be pretty tough. Most of the time, we use either two-factor or multi-factor authentication. So two-factor means you have to know two things. Multi-factor means you have to have two or more. So really, there's not a lot of difference between the two. If you've got an online banking site, you most always have to have now two-factor. So it's a pain. You log into your bank, and not only do you have to type in a password, but you have to remember, like, your mother's maiden name or something. Or they will text you an authorization code. Well, we use one here called Duo for a lot of our stuff, where we have that multi-factor authentication. So we get into it in our cybersecurity a lot about different types, but it can be something something you have. So maybe it balances off of your ATM card, or you have a YubiKey or something. Something like your fingerprint, iris scan, palm print, whatever. It can use location, so geofencing again. It can even look at how you do something. And one of the interesting ways we're doing it is looking at how people type. Because what we've discovered is that people type in fairly unique ways that we can use to actually identify if you are who you think you are. Or who we think. Anyway, as another piece of information. So, multi-factor or two-factor says you have to have two of those. So maybe a password, and then maybe a security token. Maybe you have additional information. Maybe it's something about you. Some way that we can figure out a little more information about how you are getting there. Are you in the right spot? Are you authorized to be there? And so our hope is that you can't do both models at the same time. Hopefully. Now, if I grab somebody's phone and I'm able to log on to their phone, I may have broken two-factor. And so there's some security holes. For example, texting, it's fairly easily to spoof text numbers. So there are some issues with that. So we authenticate then. The service we typically use is something called a Radius server. And that Radius server is what we log in against, whether we're dialing in, the old model, maybe we have a VPN, we've got a wireless access point. So that Radius server uses Active Directory or other directory service to authenticate and say, hey, I am really who I am. And of course, Cisco had to come out with something a little different. So Taxis has some advantages, but again, if you're not in an all Cisco environment, not necessarily something that you can easily do. And I hate the idea of proprietary, so I'm going to go like that. Where we lead, though, is the idea of wireless security. And so I mentioned it before when we looked at wireless a little bit, that there is something called WEP, Wireless Equivalent Privacy. Don't even bother, it's horrible. If that is the only option you have on wireless is WEP, your wireless access point or router is ancient, needs to be replaced. Don't even bother, don't even try. It's not going to work. So what we did come up with was the next model. And it's actually now the third generation is now emerging. WPA3 is coming out right now. WPA is pretty tough. It's not unbreakable. There's nothing that's unbreakable at some point. But it's as close as we had, and the new version 3 is even better. So, version 2, is which most people will see on your devices, allows you to do a couple of things. So, it encrypts that entire message, including when you log in your password and your authentication credentials. And that's kind of the key. WEP, well, it really encrypted stuff once you created that connection, but you had to share the key, and you shared that key in in free space. So this is that idea of WPA. So we create this tunnel, essentially, between the server and the switch and your authenticating device, in this case the access point. So you're creating a tunnel that's safe all the way back to when you put in your credentials. The personal version uses the idea of something called a pre-shared key. In other words, I have to somehow distribute that to you. That works. Again, the scary part is, how do I share that key? So if you're going to use pre-shared key in a business setting, you need to probably change that fairly often, because all of a sudden everybody has the pre-shared key. Word gets around pretty easily, unfortunately. So the enterprise version works a little differently. The enterprise version then says, well, not only do I going to have to come up with an answer, but that answer doesn't lie in the access point. It actually lies in this authentication server. So maybe it's the same login I used for my Active Directory, or I use a single sign-on system, and it authenticates me on that system that way. So I can set up users quickly. I can deny users access if I need to. And on the commercial enterprise side, I'm using TLS for that entire link. And so I use a certificate server. So it gets a little more complicated to set up, but my security is a lot greater. A lot greater. So I'm not going to go into a whole lot about how security certificates work, because I want to get through some of this. But what you're essentially doing here, so protected EAP, everything from the computer to the server and all of our data is all in that encrypted tunnel. It's scrambled. Nobody can see it. I can grab that wireless signal, but it's meaningless. It doesn't have any ability for me to get it back. And the security certificates ensure that. And so it allows me to create that. So business side, large business, I'm doing something like a Radius server. I'm going to that effort. I'm putting in wireless determined by an authentication model. Smaller business, I can get by with that home version, the WPA2/3 that's coming out, and I can share a key with people because I don't have typically a ton of clients on there. But if I'm a large corporation, I've got a couple hundred clients that are going to be on wireless, I'm going to be putting in an authentication server. So our book lands us with this idea. Hey, great, and here's another tunnel that's developed by Cisco. So I'm not sure why this chapter seems to be a Cisco written chapter, and I apologize for that, because I try to be as vendor neutral as I can. Cisco is probably the leader in a lot of this stuff, quite frankly, but I hate the idea of proprietary software so that I can't work with one vendor to another. That always kind of bothers me. So in other words, if I had an all Cisco system and they were completely proprietary, unless I had a Cisco wireless adapter, I couldn't get on that network. Now, it's not the case with this because it'll default back to PEEP, but I always want to be cautious of that when you're designing a network, to make sure of that. All right, so that is this chapter in a nutshell. And I want to look at what's in here and tell you a little bit about what's going on this week. So Cengage and I have fought, battled, and I am going to go out and try to manually this week. And I ran into a weird issue with people that have a 0 at the beginning of their student ID, because that's how I can manually move stuff over in bulk, is it keys off that student ID. Except for some reason we've created NUIDs that start with a 0, or in fact somebody in our class actually has a 00 at the beginning of their student ID. It creates a little bit of a headache in terms of moving that data over. But I'm going to grab probably the first, we're in week 12. I'm going to try to probably grab weeks 1 through 10 probably. And I'm going to move all that stuff over from Cengage in a big manual move. And if I have to do it by hand and start typing in numbers, I'm going to be a grouchy bear. But I will get that moved over because it's kind of ridiculous. They haven't come up with a better way for me to do it at this point. Thank you, Cengage, whatever. So we will move those over. What those amount to is about 30% of your grade. So if you're at a 60% and you've done all of them, it'll probably bump you up. If you're at a 70% and you haven't done any of the Cengage stuff, it's probably going to bump you down. So just be aware of that when I start moving those over. That said, this would be a good week if you're missing some of those to go in and grab those and get them done before I make that giant move over. So this week you have a quiz and there are 2 simulations. This one, because it's new and different, unless you're used to working on the command line in Ubuntu or a Linux type system, is probably going to take you a little bit of time. The other thing I will say is the password they use for that would drive me crazy if somebody actually used that as a live password on a system. But they actually use a version of the word password with some leet speak in there. But you'll notice that. So the other piece that you have this week is there is a discussion board. So the discussion board, may not go a little further. So you found a new job. Now you're going to be in charge of, after reading this description, you're going to have to come up with a data backup plan for this organization. Yikes. But when you graduate, that may well be something you end up doing. If you go to work for a smaller company, they may not know about data backup. That may be a mystery to them, or they're doing something else that's really, really odd. So that's your 2 assignment pieces this week. So make sure you get those done, and then we will move that over manually then on those grades and those scores.